Hello all, welcome back for the introductory session on control systems. So in this part of control systems, we will cover the introduction, terminology and types of control systems. So basically types of control systems are two types. One is open loop systems and second one is closed loop systems. So these are the contents that will be covered in this control system class, and it's going to be a very short video. Hope you guys can understand it, and you can keep on watching this video as soon as if you want to refresh any of the concepts of control systems. So we'll go ahead with the introduction. So control system is systematically arranged interconnection of components which together act to provide a desired response when excited by an input. So this is what is exactly control system, right? So for example, if you look at the system, the diagram over here, so it is having one process is there. For that process there will be an input, and whenever an input is being given, the process has to provide a required output. Correct? So such a system is called as a control system. Okay, so that's why it has been told that systematically arranged interconnection of components which together act. That means this process will be having what? This process will be having many components. This process can be a particular plant. Okay, what do you mean by plant? You can take it to be as one industry. Right, so an industry will be having many components. For example, if you consider any machine in an industry, okay, so that machine will be having many components, right? So that machine takes an input and provides a required response, right? So examples, what are the examples for that? So we can take that temperature control of in a building. So that could be the good example, right? Normally to do this we will be having AC. So AC will be controlling the temperature of that particular building. So the AC will be having sensors. So these sensors will keep on having a watch on the temperature of a room, and based on that it will try to keep the temperature in a controlled fashion. The second example could be a speed conveyor belt in a process plant. The third example, this is a well-known example, that could be a microwave oven. Then the fourth will be an industrial automation systems, etc. Right? So these are the four examples. There could be many more examples which we are using in day-to-day life. Okay, you guys can find out and try to relate that examples, that how such a system can operate as a control system. Then there are various terminologies so that are related with control system. First one is plant, second one is process, third one is command input, reference selector, and disturbance. So what do you mean by plant? The plant is the dynamic unit or equipment containing components to perform an operation is referred to as a plant. The very good example for us, that one is a CRO and can be an aircraft. So what does it mean? It's an equipment containing components. The CRO will be having what? It will be an equipment which contains many components. So it performs some operation, might be measuring of a wave, and an aircraft normally it is used for flying purpose and all. So it's an equipment which contains many components. Then second one is process. A progressive continuing operation with gradual changes leading towards a specified result. That's what we saw it here, right? So here this process will be having what? It's a gradual. As soon as we gradually change the input, this process will respond so that it will give a corresponding output, right? That's what is a process mean. Then third one, command input. What is command input? It's a motivating input signal having full control on the system which and is independent of the output, right? So that means what? If you are having a plant here, this one is a plant P, and then you are going to give an input signal, right? Then you are going to give an input signal. This input signal is independent of the output. That means you can keep on controlling the input without considering any of the parameter of output. Then similarly, we are having one more parameter which is nothing but reference input. It's a form of input directly usable by the system, right? Also called as actuating signal, right? So reference input mean what? Suppose if you are having a system, this will be acting as an input, right? And there will be one more input will be there, that is considered as a reference input. So it is a form of input directly usable by the system, right? So this reference input normally is used as a reference purpose, okay, so that according to this the particular input will be adjusted. That's what is called as reference input. Then when we are having a reference input, we will be also having a reference selector. So what do I mean by reference selector? Unit that establishes the reference input, also called as a comparator or controller. Then the last one is disturbance. A signal which tends to adversely affect the output is called as disturbance, right? So here, if I want to get a particular output, that output, if it doesn't comes, for example, if I want 5 volt output, if it doesn't comes, if I get 4 volt output, that means what? There should be some disturbance might be there in the system, right? This disturbance might be there as an input, that means in the machine, or else this disturbance might be also there at the output also. Might be there is some temperature variations might be there or something, right? So that disturbances will affect the output. Then the last part of this video is what are the types of control systems, right? This is a very much needed concept. So if the control system doesn't have this one, we have seen that this is a control system, right, which is having an actuating device, and then we'll be having a process. Suppose if we are not checking the output, right? So here you can see that the input is there and then we are having an output. So the input is not at all related with the output, right? The input is not at all related with the output. Then such systems are called as open loop systems, because you are not feeding any of the part of the output to the input. Whereas if you are feeding any of the part of the output to input through a device, through any device, right, through any device, or through any device, then it is called as a closed loop system, right? So in general, if you are not looking at the output, then it is called as open loop control system. If you are feeding the part of the output to input, then it is called as closed loop control system, right? So this is also called as closed loop feedback control system, because we are taking the part of, we are looking at the output and then we are feeding a part of the output to input. So that's why it is called as closed loop feedback control system. Okay, so this is a very short video which covers the introductory part of control systems. Thank you.